Alright, in this video we're going to introduce the subject of trigonometry. So in the introduction we're going to talk about, we're going to define angle and introduce some terms that are relevant in the architecture of angles. So an angle is formed at the intersection of two half lines. So what we do is we imagine that, for starters, we have got two lines like this, and then we tilt this one. We can either tilt it counterclockwise or clockwise. I'm going to start with the case where we're tilting it upwards in the clockwise direction. So if imagine that this line now ends there, then we now have an angle here, and we are going to call this angle theta. Then the position where both lines started is called the initial side, and then the position where this other line finally ends is called the terminal side. So this is called the terminal side. Okay, and then angles formed in the counterclockwise direction are called positive. So this theta here is going to be positive. Of course, we could form an angle by rotating or tilting that line in the clockwise direction like this, in which case that angle is going to be called a negative angle. Notice that this is different from the convention, for instance, on bearings, because if you will remember, on bearings all angles are measured from the north, and in that case the positive is clockwise. So that would be a bearing of 90 degrees clockwise. But in the case of trigonometry here, we would define an angle to be positive if it's in the counterclockwise direction. Now, so just a reminder, of course, an angle could be acute, an angle could be reflex, well, I can't remember whether that's obtuse, or could be reflex. No, I think that's obtuse. And then an angle could be reflex. So this is obtuse, this is reflex, this is still a reflex. So that's just the definition of an angle, how it's formed. So it's going to always have two sides. Now, what we're going to be interested in next is what we call angles in standard position. Right, so before we talk about angles in standard position, we just need to mention that the point where the two lines meet, this one here, is called the vertex. So that's the initial side, and that's the terminal side, and the point where they meet is the vertex. That's the vertex of this one, etc. Now, an angle is said to be in standard form, standard position, if its initial side coincides with the positive x-axis and its vertex coincides with the origin. So what's going to happen here is we're going to mix trigonometry with geometry. So we're going to do our trigonometry on the xy axis. So we are always going to imagine that our initial side is along the positive horizontal axis, and then the terminal side can either be in the first quadrant, it can be in the second quadrant, could be in the third quadrant, could be in the fourth quadrant. The terminal side is in the first quadrant, then our angle is acute. Along the vertical axis it's the right angle. If it's in the second quadrant, our angle is obtuse. If it's in the third or fourth quadrant, it's reflex. Okay, so that's an angle in standard position. Just for now, we're going to focus on the case of an angle in the first quadrant. So if this is our angle theta here, then you could imagine this is a point with coordinates xy. That's a point with coordinate xy. It means the length of this horizontal side is x, and the length of this vertical side is y. Then the hypotenuse by Pythagoras is going to be the square root of x squared plus y squared. So once we have got this situation, then we can now define the trigonometric ratios of this angle theta. We're going to start with sine theta. Notice that r here is always going to be positive, so the hypotenuse is always going to be positive. So let's define the trigonometric ratios. So sine theta, so we know that sine theta is opposite of a hypotenuse, so in this case opposite is y, hypotenuse is r, so sine theta is going to be y over r. Cosine theta is going to be x over r, and tangent theta is going to be y over x, is opposite over adjacent. Along with these three trigonometric ratios, we introduce three other related ratios. Actually, before we continue here, we notice that tangent theta can also be defined as sine theta over cosine theta. If you take this one and divide it by this one, you get this one here. So there is another trigonometric function which is just defined as the reciprocal of sine. And it's called cosecant. So maybe let me do this one here. So cosecant theta, which we're going to abbreviate CSC of theta, is simply 1 over sine theta. So it's going to be r over y. Then there's something called secant, and which we're going to abbreviate SEC of theta, sec theta. So that one is 1 over cosine theta. So that's going to be r over x, which is just the reciprocal of this one here. And then lastly, we are going to define cotangent, and cotangent is just going to be the reciprocal of tangent, abbreviated cot theta, is 1 over tangent theta. Now since tangent theta is sine over cosine, so this one is cosine theta over sine theta, So it's going to be x over y, because tangent is y over x. So now we have got all six ratios, if you like. Okay, the last thing we're going to do in this video is to look at the signs of the trigonometric functions in the different quadrants. Okay, so this is quadrant 1, this is quadrant 2, quadrant 3, this is quadrant 4. We know that in quadrant 1, x and y are both positive, and quadrant 2, x is negative, y is still positive. Okay, in quadrant 3, both x and y are negative, so x and y are less than 0. In quadrant 4, x is positive and y is negative. Now, so remember, sine theta is y over r, cosine theta is x over r, tangent theta is y over x, and we said r is always positive. So whether this is positive or negative is going to be determined by the sign of this. This one, the sign of this one, both x and y. So if we look at the first quadrant, both x and y are positive. So that means sine is going to be positive in the first quadrant. Cosine is also going to be positive, and tangent is also going to be positive. So in the first quadrant, all of them are going to be positive. So I'm going to write here, all are going to be positive. Sine, cosine, and tangent are all positive. In the second quadrant, x is negative, y is still positive. So that means y is positive, so sine is going to be positive, cosine is going to be negative, tangent is going to be negative. So that means in the second quadrant, only sine is going to be positive. I'm going to write here, only sine theta is positive. Then in the third quadrant, both x and y are negative. So that means sine is going to be negative because it's going to be a negative number divided by a positive number. Cosine is going to be negative. But here we're dividing a negative by a negative, so tangent is going to be positive. So in the third quadrant, only tangent theta is positive. Then in the fourth quadrant, x is positive, y is negative. So that means this will be negative, this will be positive, this will be negative. So that means here only cosine theta is positive. So this information is going to be very important for basically everything we are going to do from now onwards. There are different ways of remembering this. Some people use the mnemonic all students for us here take cocaine, or something like all students take coffee. Okay, but remembering this as we go on is going to be very important. All right, in the next video we're going to look at something called coterminal angles, and also something called the reference angle.